Jai Shri Gurudev. Myself, Mrs. Lata, is Assistant Professor from Department of EC SJBIT. Today we'll be giving you a brief introduction about an interesting subject with the title as Control System, which is one of the core subject in 4th semester. The subject code is 18EC43. In today's session, I'll be giving you a brief introduction about control systems, syllabus, textbooks, and the prerequisites that is required to understand this subject, along with few important preliminary concepts. This is the outline of my presentation for today. First, I'll be giving you a brief introduction about the course, recommended books, prerequisites of the subject, followed by the basic definition of control system, types of control system, transfer function representation, followed by stability analysis of the control system. This is the syllabus of control system subject. CIE marks is 40, SEE marks is 60, and the credit points is 3. Coming to the course learning objective, this course will enable the students to understand the basic features, configuration, and applications of control system, and various terminologies and definitions of control system. And also the students will be able to find the mathematical model representation of electrical, mechanical and electromechanical systems. Students can also find the time response from the transfer function using a formula termed as Mason's gain formula, and also stability of the system can be analyzed using the transfer function representation. So these are the course learning objectives of the subject. Now coming to the syllabus, we have 5 modules. In first module, basic concepts of control system is taught as an introduction. So under this module, we will discuss about types of control system, effects of feedback systems, differential equation representation of physical system, mechanical system, electrical systems, and electromechanical system is discussed, along with analogous systems. In analogous system, we will discuss about 2 types of analogy, that is force voltage analogy and force current analogy. So that is the content of first module. Coming to second module, here we will discuss about the block diagram representation and signal flow graphs. So the first topic we are going to take up under this module is transfer function representation for the system, followed by block diagram algebra, where we will discuss about block diagram representation of the system along with reduction rules. And the last topic in this module is signal flow graph representation, wherein block diagrams will be represented using signal flow graphs, and using the Mason's gain formula, the transfer functions will be evaluated for the given signal flow graph. In module 3, we will discuss about time response analysis of feedback control system, under which we will discuss about standard test signals, and we will study about unit step response of first order and second order system, followed by time response specifications of second order system. And then finally, another important topic will be introduced to you here, that is steady state errors and error constant. Along with this, few controllers are introduced in the syllabus, that is a brief introduction about PI, PD and PID controllers are discussed here. In fourth module, we will discuss about stability analysis of system in time and frequency domain. So in time domain analysis, first the concept of stability will be taught, followed by necessary conditions for stability, under which an important technique will be discussed, which is named as root stability criteria, followed by relative stability analysis. And also the few more important concepts on root stability criteria will be discussed in the first part of stability analysis. Along with this, in the second part, we will discuss about another important time domain stability analysis technique named as root locus technique, wherein we will discuss about root locus concepts, construction of root loci using different rules, and the sketches of root locus diagram will be drawn here using the graph sheet for the analysis. In the second part of module 4, we will take up frequency domain analysis of control systems, wherein you will learn about correlation of control systems behavior in time and frequency domain, and you will be able to find the response in both the domains. Stability analysis of control system in the frequency domain using Bode plots. So in Bode plots, we are going to use the similar graph sheets to draw the plots for the stability analysis, followed by experimental determination of transfer function using the Bode plots. So this is the content of module 4. In fifth module, we will discuss about frequency domain analysis of control system using other techniques, wherein a brief introduction to polar plots is given along with mathematical preliminaries. And another important stability criteria which we are going to take up here is Nyquist stability criteria. So this is about stability analysis in the frequency domain. Now after this, a brief introduction to the compensating networks is given, wherein we will discuss about lead lag and lead lag compensating network. So you can expect one theory question on this. And in the last topic of module 5, we will discuss about analysis of system using state variables. Under this particular topic, we will discuss about concepts of state, state variable, and state model for electrical system, followed by solution of state equations. So this is the brief overview of the syllabus what we have for this particular subject. This is the course outcome which we have for the control system subject. So in this particular subject, we have evaluated 5 course outcomes. So CPO1 tells that here in this course, the students will be able to develop the mathematical modeling of mechanical and electrical systems. And the second course outcome of this particular subject is develop transfer function for a given control system using block diagram reduction techniques and signal flow graph methods. Course outcome 3 for this subject is determine the time domain specification for first and second order systems. And the fourth course outcome is determine the stability of the system in time domain using Routh-Hurwitz criteria and root locus technique. The fifth course outcome is determine the stability of the system in frequency domain using Nyquist and Bode plots. So students need to have an idea about these course outcomes. Course outcomes are nothing but the knowledge what the student is going to gain once the student completes that particular course. Coming to textbooks, syllabus is framed according to the given textbooks here in the slide. The textbook from which the syllabus is framed is Control System Engineering by J. Nagrath and M. Gopal, 5th edition, and the details of the books are given in the slide. Along with this, you can refer few other textbooks which are listed. So the first reference book is Modern Control Engineering by K. Ogata, 4th edition. And the second reference book is Automatic Control Systems by Benjamin C. Kyo, 8th edition. Feedback and Control System by Joseph J.D., 2nd edition. So these are the 3 reference books which can be considered for the syllabus. Now coming to prerequisites, the prerequisite knowledge which is required to understand this subject is the student need to have a knowledge about differential equation representation, Laplace transform evaluation, basics of physics, along with that use of ordinary and similar graph papers should be known. Okay. So to understand the modern control theory, an idea about linear algebra and matrices is required. So this is the brief prerequisites of the subject which is required. Now Now let's start with the first module, which gives a brief introduction to control system, wherein we will discuss about definition of control system, components of control system, classification of control system in today's session. So this is the content of the entire module, which I've briefed already. So introduction, types, effect of feedback, differential equation representation of physical and mechanical systems, electrical systems, electromechanical system and analogous systems. So first let's start with the basic definition of a control system. So as the name indicates, a system is a basic unit consisting of an element or a number of elements which work together to achieve a particular function. So there will be a number of elements which are connected together and they have to work in coordination to perform a particular operation or a function. So a system controlling the operation of another system can regulate itself, or it can also regulate another system. So a system has all these capacities. It can either control the operation of one more system or it can regulate the operation within itself. So that is one behavior of a system. So this controlling is done by using a controller. Okay. So a control system is a device or a set of devices uh, which can manage or command or direct or regulate the behavior of other devices or other systems. So controlling action is very much important, because if I can take an example of a human body, in a human body, the human brain itself is considered as a controller, which is controlling the entire organs of our human body. So human body itself is a simple example for a control system. So where the entire controlling is in the hands of the controller, which is nothing but our brain. So all the functions are carried out in a controlled manner. So for any system, if we can consider, we always need to have a controller to have a control over the function of the system. So this is the basic definition of a control system which you need to know. So coming to the simple block diagram representation of a control system, as discussed in the previous slide, system is nothing but an interconnection of elements or devices to obtain a desired operation or to perform a desired function or to perform a desired purpose. So here a simple block diagram of system is shown. So we have a process here with an input and an output. So an input is given here. So this will be processed to generate a particular output. So process or plant. So another name for the process is also called as plant. So the device plant or the system under control is represented using the block diagram as shown here. It receives an input and generates an output. So always the input or output need to have a good relationship with each other to perform a particular operation in a proper way. Okay, so this is general representation of a system. Now, here there is no control. The thing is, the previous diagram what I showed you did not have any controller. So here in that case what happens is, when I give some input, it will process according to its own requirement and it will generate the output. We will not have a control over the behavior of the output. For that purpose we need to have these three important things, that is controlled variable and manipulated variable. So control variable is defined as a quantity or a condition that is measured and controlled. So this is obviously considered to be the output of a control system, and manipulated variable is nothing but a quantity of condition that is varied by the controller so as to affect the value of the controlled variable. So manipulated variable is nothing but the value that is fed back to the controller to take a proper decision. And the third important unit that we must have is control. Control means measuring the value of a control variable of the system and applying the manipulated variable to the system to correct the limit or the deviation of the measured value from the desired value. So for example, if I have a heating system, if I want to have a temperature of 80 degrees centigrade, okay, that is my desired output. Okay, now for example, if I'm giving some input temperature and if I'm getting the output temperature to be 60 degree, okay, there is a difference of around 20 degree. So your output, whatever you have got, it is not desirable, so now it has to be manipulated. So again you will feed a manipulated variable to the controller, where your controller will take a decisions that the temperature needs to be again increased by 20 degree, and that operation will be indicated to your process or plant, and the necessary action will be taken. So this is the advantage of having the controller in a system. So the system along with the controller is very much essential for any device which we are going to design. So this is the basic definition of control system. Now coming to definition of control system, this is the basic block diagram representation of a control system, which is incorporating a controller along with the process. So here input could be a reference input or it could be a set point which is given for a controller. The controller will generate the manipulated variable that is required to perform an operation for a process, and the processor will do the operation on the given variable, and it is going to generate the necessary controlled output value. Okay, so this is the basic block diagram of a control system. The one disadvantage what we can have in this is we can have disturbances. So a disturbance is nothing but a signal that tends to adversely affect the value of a system, and it is considered to be an unwanted input, and this can be avoided in a system by using necessary measurements. So if a disturbance is generated within the system, it is called as internal disturbance, or else if it is generated externally, it is considered to be an external disturbance. So when we deal with control system, obviously we need to know four important terminologies in the block diagram representation of control systems, that is plant, feedback, controller and error detector. So this diagram I've already shown you people. So I have a controller process, or it could be represented as a plant, and we have an output or a controlled variable. It's also called as control variable. So these terminologies we must remember with respect to any control system which we are going to design. So, and these are considered to be the basic components of control system, all these four components, that is plant, feedback, controller and error detector. Now plant is nothing but considered as a portion of system which is to be controlled or regulated, and these are called as plants or process, and it is a unit where actual processing is performed. And if we observe in the previous figure, the input to the plant is from the controller, okay, and plant performs necessary action on a controlled system and produces the desired output. Okay, and feedback, if you can take, it is very important for a control system, because always whenever we are unable to get a proper output, so that has to be fed back to the error detector, and uh, the deviation in the output should be measured in the error detector, and that should be given to the controller. So that is what is done by the feedback system here. So it is a controlled action in which the output is sampled and a proportional signal is given as an input to the correction unit for any changes in the desired output. Okay, and when we are feeding back this output back to the correction unit, we can have two types of feedback: positive feedback and negative feedback. So generally negative feedback is preferred to have better stability and accuracy in many of the system. Now coming to the error detector, the function of the error detector is to compare the reference input with the feedback signal given from the system, and it produces the necessary error signal, which is nothing but the difference of the reference input and the feedback signal. And this error signal, whatever is generated from the error detector, is fed to the controller to take the necessary control action. And this error signal is always used to correct the output if there is a deviation in the desired value. That is what I told you with an example of a heating system. So if the actual desired temperature is around 80 degree and if I'm getting the output to be 60 degree, then the error difference in the temperature measurement will come around 20 degree, and this is considered, this difference in 20 degree temperature is considered to be the error signal, which is detected using the error detector, and this error detected value will be given as an input for the controller to take the necessary action. And the next and important part of the control system is controller, which is considered to be the heart of control system. And this is the element of a system within the control system, or it could be from an external system. So what this does is, whatever error signal is generated from the error detector is given to the controller. So this error signal will be a weak signal, so the controller, it has to amplify this signal and modify the signal for better control action. Okay, so we have an amplifier within the controller itself to amplify these kind of weak error signals, and then based on the error input what the system has generated, your controller will give the necessary controlling action signal to the process or your plant to correct the errors which has occurred. So these are the four basic elements that we have in a control system. So this is a brief introduction about the control system subject. So in today's session, I've given a brief introduction about the syllabus, required textbooks, prerequisite knowledge which is necessary to understand the subject, followed by a brief introduction to control system, where you have learned about basic definition of a control system, what are all the requirements for a control system, the basic components. So in the basic components we have discussed about process or plant, feedback, error detector and controller. So this is the glimpse of the subject. In the next session we will in detail discuss about the different types of control system with examples, followed by transfer function representation and differential equation representation. So I hope this session was interesting. Thank you one and all. Have a nice day.